Lesson 4.3 is determining whether figures are similar, and then if they are, we're going to go ahead and find missing dimensions in the similar figures. The first thing we need to do is understand some of the vocabulary, though. We need to understand what a similar figure is, or what it means to be similar. So similar means that the figures are the same exact shape, but not necessarily the same size. So they are the same shape, but not necessarily the same size. So they could be actually the same size, and those similar figures would be called congruent, or they could have one that's smaller and one that's larger. Next, we have what are known as corresponding sides, and corresponding sides are sides that have the same relative position. So when you look at the similar shapes, then you look at the sides that would match up from those similar shapes. They're in the same relative position, and those are called corresponding. And the same with corresponding angles. They're angles that have the same relative position. You look and see, are they in the same spot from the smaller figure to the larger one? Here, if we have similar polygons, it says for two polygons to be similar, two things have to happen. One, the corresponding angles must have equal measures. So the corresponding angles, the angles that are in the same relative position, must have the same measure. And two, the ratios of the lengths of the corresponding sides, so ratio, remember, is a fraction. Corresponding sides are the ones that are in the same relative position. They must be proportional. And remember, to be proportional, we can do a cross product and see if the products are equal. So here they give us two triangles, ABC and FEG. And these are examples of similar triangles. Angle A is in the same relative position as angle E. You can see that this is turned. You have to be careful. It's actually been flipped over. The reason that I know that they are the same relative position is that angle A is 53 degrees and angle E is 53 degrees. And remember, over here it says corresponding angles must have equal measures. So A and E have equal measures. And B is 37 degrees, so I march over here and look. Oh, F has 37 degrees. So these are corresponding angles. And C, this is a right angle right here. And a right angle, remember, has 90 degrees. And C and G have corresponding, they're corresponding, and they have exact same measures. So we write the vertices of the triangles in order of their corresponding angles. So A went with E, B went with F, and C went with G. And this little tilde right here from Spanish, that is the symbol in math for similarity. So that means similarity. Here we're just looking, we wrote the corresponding parts, and here are the corresponding side lengths as ratios. So A over B, and let's write this to the side, that's 60. That corresponds, so A over B corresponds to E over F, so EF is 30, and that should be equal to BC right here and FG. So BC is 48 and FG is 24. And then our last sides are AC, which is 36, and EG, which is 18. And one way I can tell that these are all the same ratios is I could simplify them. This simplifies to 2 over 1, 2 over 1, 2 over 1. Or I could have done cross products, and I would have seen that all of these will end up equaling the same cross product. All right, let's do one together, the next one. Which rectangles are similar? Remember, rectangles have 4 right angles. So I know that all the corresponding angles are congruent. So all angles are congruent here. So I have to look at the ratios of the corresponding sides. So 10 in rectangle J corresponds to 5 in rectangle, oops, silly me. 10 corresponds to 5. And the 4 in rectangle J corresponds to the 2. And in the others, 10 corresponds to the 12, so I would put the 12 up here, and the 4 corresponds to the 5 again. And so I can simplify these. This one simplifies to 2 over 1. 2 over 1. Yeah, this one doesn't simplify to 2 over 1. It's just 12/5. So these two are proportional. So that means rectangle J is similar to rectangle K, and that's it. In example 2, we have a picture that's 10 inches tall and 14 inches wide, and we're going to guess that that's a rectangle because it's a picture. And it needs to be scaled down to 1.5 inches tall so that it can fit on a web page. So we need to figure out how wide the picture should be so that it fits on the web. So the 10, I'm going to do actually tall over wide, like we did a couple lessons ago, and it's 10 inches tall over 14 inches wide, and that is proportional to 1.5 inches tall, and I don't know how many inches wide. Now I just do the cross product, so I get 10W, 14 times 1.5 is 21, divide by the 10, and the new width should be 2 1/10 inches. So to scale it down, it needs to be 1.5 inches by 2 1/10 inches. Next, we have a t-shirt design, and it includes an isosceles triangle. An isosceles triangle has 2 equal sides and 2 equal angles. We should say congruent to get with our geometry words. So congruent is an equal sign with the tilde above it. So if we just look at this, we can draw this, and the original is 4.5 inches, 4.5 inches, and 6 inches. And then the one that's going to be blowed up is 3 feet, 3 feet, and I don't know how many feet. So I'm going to go from the smaller triangle to the large triangle, and I know the 4.5 corresponds to the 3, and I need to know the 6 corresponds to what. So when I cross product, I get 4.5, x equals 18, divide by 4.5, and x equals 4, and this is in feet. Okay, the rest of these problems are for you to do on your own. So show your work and bring them in tomorrow, and we will discuss them. I will be checking to make sure that you have these completed.